All right, we're going to go ahead and finish up the last part of this unit. So if you will turn in your packet to page 15, we'll be able to get started. We're going to be looking at frequency tables, okay? So, all right, so what is the number of 10th graders who spend 2 to 4 hours on homework? So if I look at, I'm going to have to look at two separate things. First thing I want to look at is 10th grade, and that's the only set that I want to look at. All right? The next thing that I'm going to look at is the amount of time, which is 2 to 4 hours. So if I look at the 2 to 4, 2 to 4 is here. So I'm going to see where these two meet up. This is a conditional frequency. And if I find where these two meet up, we have the number 25. So our answer would be 25. So that is the number of 10th graders from these classes that spent 2 to 4 hours on their homework. Okay? All right, so we're going to look at marginal frequency. For some reason, our table isn't showing up on here, but it's the exact same one that we just used. And that is the total number. So marginal frequency is the total number of times a response was given. All right? So A, and you can look back at the top of your page because you have the table. What percentage of 10th graders spend 2 to 4 hours on homework? So we're looking for a percentage, okay? So we're going to have to see, and I'm just going to go ahead and out to the side because, or I'll go back. So we're going to look at this chart, and we're going to add all of these columns up, okay? So if I go down through here, 0 to 2 hours, the total number of students that spent 0 to 2 is 73. Okay? The total number of students that spent 2 to 4 hours is 55. The ones that spent more than 4 hours is 31. All right, now we want to know how many 9th graders total are there. So if we add straight across for 9th grade, we get 52. For 10th grade, we get 55. And then for 11th grade, we get 52. All right, so that's what you're going to need to answer the next two questions, okay? So what is the percentage of 10th graders that spend 2 to 4 hours on homework? Well, we know that 25 students spent 2 to 4 hours that were 10th grade. But we need to know the total number of 10th graders. So if we look at that, we see that there are 55 total 10th graders. So to find the percentage, we're going to divide the number of students, or the number of 10th graders that studied 2 to 4 hours, and divide it by the total number of 10th grade students. So you're just going to fraction button, and then you're going to take and divide 25 by 55. Now remember, if you press equals, it's going to still give you a fraction. Press that S2D button, and it will give you your percentage, which it gives you the line over it. We want the percentage, okay? So we're going to move this over 2 times. So 45% or 46% because that keeps repeating. All right? What percentage of all students are 10th graders who spend 2 to 4 hours on homework? Well, again, we know that this value is 25. But we want to know the percentage of students, okay? Of all students, sorry. So we're going to have to add 52, 52, and 55, which would give us 159 students. So there's a total of 159 students. Now we're going to do the exact same thing that we did just a minute ago. Okay? So our whole is right here. Our part is the 10th graders who spend 2 to 4 hours. So we're going to divide our part by our whole. So 25 divided by 159. Again, put that in the calculator. You get 0.15. We want a percentage, so it is 50%. Okay? So you are just taking and dividing the part that it asks you about by the whole that it's asking. All right. So the next thing that we're going to look at is data or scatter plots. And you've got to refer back to everything we've done this year, and you're going to have to see which function each of these scatter plots look like. All right. So first of all, remember that a scatter plot is a graph of sets of data. Okay. They don't need to be connected. Leave them as dots. There are some examples. Okay. All right. So now, if I look at this one, I'm not connecting these dots. But if I was to, which function did this look like that we have dealt with before? Okay. I'm going to give you a second to think about that. And then I want you to look at your answer choices. If I look at my answer choices, I have an exponential function, which is right here, and the rest of these are linear. And that's just going by what knowing your x value is. This one, our x value is the first one, a, our exponent is the x. That's why we know it's an exponential function. Remember, they start off really slow and get to really high quick. Or they start off dropping really fast and then kind of level out. Linear function, our x does not have an exponent with it. So technically there is a 1 there, but it's being multiplied by nothing else except the coefficient, so those are a straight line. Remember linear? Let's go back, I'm going to write these down. So if we had an x squared, it's going to be that parabola. We have an x, it's going to be a straight line. And then if we have, and I'm just going to use this 2 to the x, if we have an exponential function, it's going to look something like this. So which choice does this graph look like? And it would be A if you guessed that. You're correct. All right, if we look at the next one. All right. Now you can kind of look back at the ones that I just wrote and see which ones this one looks like. So if I look at these 3 right here, which one does that one resemble? X squared, the x, or the 2 to the x? I'll give you a second to pick. And if you chose B, you are correct because we have the x squared. All right. Next, we're going to look at the correlation. There are different types of correlation. There's positive correlation, there's negative correlation. Positive, this goes back to what our coefficient is. If it is a positive out front, it is a positive correlation. And that means it's going uphill. If it is a negative out front, it is a negative correlation. That means it's going downhill. So if I look at these 2 graphs I'm given, this one is going up. So it is a positive correlation. If I look at the second one, and remember, these are not going to all connect. We're not trying to make them connect. We're just getting a general idea of what the picture looks like. It's going downhill. That is a negative correlation. Okay? So that's the first thing you're going to look for in these. All right. Now the correlation coefficient it has a number. We know if it's positive or negative. Positive is going uphill, negative is going downhill. Now, we look at how close our data is. So if it is points that are very, very close to each other, that is going to be a 1. If they are spread out, it is a 0. If you cannot get a straight line anywhere in there, it is a 0. Now, if they're close but they're not too close, that's going to be a 0.5. So you have 3 values. You have a 0, a 1, and a 0.5. And then you're going to have to put the positive or negative with it. So, if I look at this first one, it is going downhill, so it's a negative. And if I look at that line, those dots are very close together, so it would be a 1. If I look at the next one, they're going downhill, so it's still a negative. But they're not that close to the line. They are making a line, but they're a little bit more spread out. So that's a 0.5. Okay? We look at the next one. Put a line down the middle. That really doesn't do anything. Our data doesn't look like it goes to that at all. So let's go to the other side. Okay? If I look at this and I put a line straight up the middle, those are going uphill, so it is positive. But it really, my points don't get really close. I have some that are spread out, so that's going to be a 0.5. If I look at the last one, if I put a line straight up through there, and if I could have done that right in the middle, those are really tight together, so that would be a 1. It's going uphill, so it's positive. Let's try this other one again. All right, so I put a line, a positive line going straight up through there. If I look at that, they're still not close. So they don't really have a negative slope. They really don't have a positive slope. They're kind of just spread out everywhere. So my value for this one is 0. All right. So now I want you to pause the video a second and see if you can figure out. You're going to give it a positive or a negative. And then you're also going to tell if it is 1, 0, or a 0.5. Okay? Once you've tried it on your own, unpause the video and you can try it with me or make sure you got the same thing I did. Okay? All right. So if I look at this first one, if I look starting at 0, my points are going up. So it is a positive. Those are not that close together. So although they are making a positive line, they're not tight, so it's going to be a 0.5. If I look at the next one, if I start from the left and I read to the right, my graph is going downhill. So that is a negative. Those are very close to that line of best fit that I drew. So those would be, or the correlation coefficient for this would be a 1. If I look at the next one, I can draw a line positive. That's really not going to tell me anything. It doesn't tell me anything about my data. If I draw a line that's negative, same thing. So we don't have a positive or a negative correlation. So that also tells us that our coefficient is 0. Our data is just everywhere. All right? All right, so the last thing to look at for this unit is going to be correlation versus causation. Okay? And you're going to look at the relationship between two things. All right, and you have to pick, is the situation a correlation or is it a causation? All right? So a causation is more of a cause and effect. One thing causes something else to happen. If you can look at this situation and say, oh, that has nothing to do with what happened first, it's a correlation. Okay? So let's move on, and you can stop and read this if you want. And then try, but I'm going to move on so you can see what we're doing. So you can have correlation without causation. So your example, there is a correlation or a relationship between the number of firemen fighting a fire and the size of the fire. So, in other words, the more firefighters at the scene means there's a bigger fire. However, bringing more firemen will not cause the size of the fire to increase. If that was to happen, that would have been a causation. It just happens to be a correlation. You know, the fire's this big, we're going to send this many people. Okay? So let's see if we can pick them out on the next examples. All right, a recent study showed that college students were more likely to vote than their peers who were not in school. Does going to college have anything to do with voting? No. So that would be a correlation. Dr. Shaw noticed that there was more trash in the hallway after second period than first period. So, does second period mean that there's going to be more trash? Not necessarily. It could be that if you're looking at Franklin County High School, there are students that don't, a lot of our students, our juniors and seniors, have work-based learning or college classes for first period, so there may not be as many students in the hallway. So just because there's more trash in the hallway after second period has nothing to do with second period. So that one is a correlation. All right, you hit your little sister and she cries. Did she cry because you hit her? Yes, that is a causation. All right, during the month of June, the number of new babies born at the Utah Valley Hospital was recorded for a week. Over the same period of time, the number of cakes sold at Carlos' Bakery in Hoboken, New Jersey was also recorded. What can be said about the correlation? Is there a causation? Why or not? Why or why not? So if we look at this, if I look, I am going up. So it's a positive correlation for this one. These numbers are staying pretty steady, so they're going to be kind of in a close line. So it has a correlation coefficient of 1. If I look at the number of babies versus cakes, as I put that, it's going up. So it is positive, and they are really close together, 1. So this table is this chart. Okay, so it is a positive correlation of 1. But is it a causation or a correlation? All right, think about it. Do you think more cakes are sold because more babies are born? No, it just happens to be a correlation. Or however they say a coincidence. Okay? So they're similar, they're alike. So similar, they're alike, but there is no causation. Because the number of cakes doesn't cause births, or vice versa. The number of births doesn't cause cakes or cakes to be bought. So, and especially when you're looking at two different places. So, you're in Utah and then you're in New Jersey. So, all right, example 2. Try this one on your own. Mr. Jones gave a math test to all students in his school. He made the startling discovery that the taller students did better than the short ones. His causation statement: as your height increases, so does your math ability. What can be said about the correlation? So, this is their score. This is their height. And he said as you get taller, your score goes up. So I would say, first of all, it's a positive. Could be a 1 or a 0.5. Seems like it's pretty close because he could tell that, or he can give that. But now, is it a causation? No. Why is it not a causation? Because, or here, let me put no causation so that way. So no causation, because height doesn't affect your math ability. Or doesn't cause math ability. Or doesn't give math ability, however you want to say it. All right, so just because you're tall doesn't mean you're smarter at math than somebody that's shorter than you. That just happens to be a correlation. All right? Example 3, try this one on your own again. In this present economy, families are trying to find ways to save money. Families might be thinking about not eating out to spend less money. Causation statement. The more you eat out, the more money you spend at restaurants. So, we eat out, and there's the money that we spend. So they're saying the more that you eat out, the more money you spend. So that would be a positive and probably a 1. So we've already discussed the correlation. Is this a causation? Why or why not? Yes, it is a causation. And it's going to be because eating out causes you to spend more. And there you go. So, just when you're looking at stuff, see if, and you're not going to have this section because you don't need this section, think about it. Does one thing happen and relate to another? Okay? If your data is very close together, it is a or it is a 1. If it is not, if it's just kind of all over the place, it is a 0. Then if it's going uphill, of course, it's positive. Downhill, it's negative. All right?